Alright, sorry for the lagging issue. Here I just want to put back a little bit about the important parts in determining the line convention, positive and negative for thin lens. Okay, so first of all, okay, object distance always compare with incident ray because it is the one that emit the incident ray, and then the image distance compare with refracted ray because it is the refracted ray that form the image. Okay, so the radius of curvature also compare with refracted ray. Only the object compare with incident ray. The rest, image, distance, radius, all compare with refracted ray. Okay, if same side is positive, real image, opposite side means negative, virtual image. Okay, so let us look at the first example. This is a convex lens. So this object, okay, first of all, I like to draw the incident ray and refracted ray first. Always draw the refracted ray. So okay, the object is at the left hand side, so incident ray come out and okay, yeah, this one object at the right hand side, so incident ray is over here. Okay, following one also object at the left side, incident ray at the left side, object at the right hand side, okay, and for the refracted ray, okay, passes through because thin lens is about refraction. Refraction means the light can pass through. The light can pass through. So the refracted ray is already at the other side. At the other side. Okay. Then ray come out. Refracted ray, yeah, and okay, and refracted ray. Same goes to this one. Incident ray and refracted ray, incident and refracted ray. Now, okay, let us look at the object distance. Okay. So here, this object is placed at the same side as the incident ray. That's why this object distance is positive. This U positive because same side as the incident ray. Okay. Now image. If the image is formed at this side, okay, same side as the refracted ray. This image is a real image. This image is a real image. V is positive. Image, okay, real image, because there is light. The light goes to the image. The light goes to the image. This image is positive. And how about if the image is formed at this side? If formed at this side means it formed at place with no light. No light. Yeah. Just now here got light. Here got light. Okay. Here got light, but here has no. Here has no light. Okay, no light. So because refracted ray already go to the other side, so image is formed here at the place opposite to the refracted ray. So this one should be the because opposite to the refracted ray. So this is what we call the virtual image. The virtual image. Because no light. Now how about the radius? Radius, okay, so look at the surface. Which surface is the first surface? This surface is the first surface. This is the first surface because it is it received the incident ray. First surface. Radius is this one. This is the radius. Okay, this is radius 1. This radius 1. Radius compare with refracted ray. Remember, radius always compare with refracted ray. So this radius is same side as the refracted ray. Okay, radius is same side as refracted ray. So this R is positive. Very simple. And how about the other side? This surface, surface 2. Okay. So this surface is surface 2. Okay, this surface is surface 2 because this is the second surface because refracted ray. Okay, this is the first surface because it received the incident ray. This is the second surface because the refracted ray goes out. And this second surface, the radius is over this side. R2 is over here. Yeah, R2 is over here. So this R2 is opposite to refracted ray. Remember, radius always compare with refracted ray. Radius is opposite to refracted ray. So this radius is negative. So that's how you put this R1. R1 is positive. This R2 is negative. That's how you use the lens maker equation. R1 is positive. This R2 is negative. Then from there you can calculate the focal length of this lens. Very simple, isn't it? So if you put the object on the other side, if you put the object over this side, then the incident ray will be over here, and then the refracted ray will be over here. So it switch. Then this one should be the first surface. This one should be the second surface. So actually it depends on where is the So this one will be the first surface, and this one will be the first surface. This one second surface. And this is the first surface, and this is the second surface. So which one is first surface, and which one is the first surface, and which one is the second surface, all depend on the position of object. You want to put the object at the left hand side, then the left hand side surface is the first surface. If you put object at the right hand side, then the right hand side surface is the first surface. Okay, so in which, you ask me which position should I put the object? I put the object at the left hand side, or should I put the object at the right hand side? Both you will get the same answer. Believe me, both you surely get the same value of focal length. So no matter you put the object at the left hand side or right hand side, you surely get the same focal length, same answer. Get back the same. So it doesn't matter. You want to put object at the left hand side, put the object at the right hand side. Which one you choose, both accepted. Both accepted. Yeah, understand? Now, let us look at the second one. Let's say this is a concave lens. So incident ray object. This time object at the right hand side. So incident ray comes from the right hand side. Refracted ray at the left hand side. So object distance compare with incident ray. So it's same place. So we can say this is a real object. U positive. Okay. Now let's say the image is formed over here. Image is formed. In fact, concave lens always form virtual image. Okay. Let's say the image is formed here. This image is formed opposite to the refracted ray. See, this is the image distance. Image distance is opposite to refracted ray. B compared with refracted ray. So with opposite means if this is negative. So this is what we call virtual image. This is a virtual image, and it's opposite to refracted ray. No light over here. Light already goes to the other side. Okay, now about the radius. Which one is the first surface? This one is the first surface. This one is the first surface lah. First surface because it received the incident ray. Then what is the radius? Radius is over here. Radius is over here, so it is also opposite to refracted ray. So this is negative. R1 is negative. So you put here R1 negative. Yeah. Then the second surface is which one? This is the second surface. This is the second surface because refracted rays goes out. The ray goes out. So this is the R2 here. R2 is over here. So this is the second surface, R2. Okay, R2 is over here because shape here is at the left hand side. So this R2 is same side as the refracted ray. Again, this is positive. Same side, positive. Opposite, negative. R1 is negative. R2 is positive because same side as the. So that's why for lens maker equation here you put R1 negative, R2 positive. Very easy, isn't it? Now let us look at the following one. This is what we call the convex meniscus. I already explained what is means by convex meniscus and concave meniscus in the previous videos. Just that the previous videos is a bit lagging, yeah, because of technical issues. So if you want to know about the convex meniscus and concave meniscus, you can refer back to the previous video, a bit lagging, but overall the front part is okay, but only the later part, the behind the video is okay. So that's why I'm making back the video part. Yeah, this is also the important. Okay, now if you want to know about convex meniscus and concave meniscus, please refer back to the previous video. Now, okay, look at this one. This is a convex meniscus. Okay, so this object is object distance is positive because same side as incident ray. Okay, this is the U positive, and then if image is formed over this side, if image is incident ray comes here, if refracted ray over here, so this image is positive or negative. This V is positive because same side as the refracted ray, so this is a real image. If the image is formed over this side, so it is opposite to the refracted ray. Opposite means negative. In negative, this is a virtual image. Okay. Now, how about the radius? Radius. Look at this radius. Yeah. So the first surface, radius is over here. Okay. This is the first surface. Here, this is the first surface because it received the incident ray. Okay, so where is the radius? Radius is over here. Follow the shape. Radius 1 over here. So it is same side as the refracted ray. That's why this R1 is positive. And then for the second surface is the one with refracted ray goes out. This is the second surface. Okay, this second surface R2. This R2 is R2 also same side as refracted ray. This R2 also positive. Very easy. So that's why that's how you put here R1 positive, R2 also positive. Okay. Now the last one, object at the right hand side. So incident ray at the right hand side, refracted side. So object distance is positive because same side with incident ray. Okay, this object is U positive, real object. Now image for this is a concave meniscus, is also like a concave lens, so you only form the virtual image. So the virtual image is formed opposite to the refracted ray. So this V is negative, this V is negative because it is opposite to the refracted ray, V negative. So this one is a virtual. Sorry, this is a virtual. Oh my god, this is a virtual image. The virtual image. Then virtual image because it is opposite to the refracted. Now, okay, about the radius. Radius for the first surface. Yeah. Then for the first surface, which one is the first surface? This is the first surface lah, because it is the one. This is the first surface. Receive the incident ray. The radius is over here. Radius 1. First surface means radius 1. So it is opposite to the refracted ray. Opposite to me. That's why it's negative. R1 negative. How about the radius 2? Radius 2 is this one because the refracted ray goes out. This is the second surface. This is the second surface because refracted rays goes out from there. So this is a radius. So here is the radius 2 again. Here is the radius 2. Okay. It is opposite to the refracted ray. Opposite to refracted ray. So this R2 is negative. So that's how you put so R1. Okay. Again. So here you can see R1 is yeah. For this one, R1 and R2 both negative. R1 and R2. So okay. Can you understand? See again, this R1 is positive because same side as refracted ray. This R2 is negative because opposite to refracted ray. This R1 is opposite to refracted ray. That's why negative. R2 is positive because same side as refracted ray. This R1 and R2 both same side as refracted ray, so both of them are positive. This R1 and R2 both are opposite to refracted ray. Yeah, opposite to refracted ray, so both are negative. Okay, so I think that's all for lens maker equation, how to determine the positive and negative sign. Very simple. I use one method to solve the whole chapters. That is, positive is where the light is. Positive is where the light is. You can use for mirror, or refraction at one surface, or lead thin lenses. Okay, solve all the problems. So that's all for these videos. Okay, next video I will explain about. Next videos I will explain about ray diagram. Ray diagram for mirror and also lenses, and also the characteristics formed by this mirror. And what is the characteristics? We have read acronyms. I will teach you about acronym. Read, rim, voom, voot, voot, which are easy for us to solve objective questions once we have this acronym. Okay, concept question, because questions quite hard. Yeah. Okay, see you in the next video. Bye.